Let's look at another material example where we'll actually make some modifications to a glass template from Arch and Design material. Go ahead and close these. We'll pick a new sample sphere. Just give it a name. And go ahead and choose glass solid geometry. Let's go ahead and assign this to this surface. And without doing any changes, let's see how that's going to look. Now you can see that that material is very transparent. In fact, with the parameters that we currently have, we can just see it in our viewport. So a couple of things we should change. One is transparency. Here it's set to 1, which is basically 100% transparent. It's unlikely that you're ever going to get something that is completely transparent. You wouldn't be able to see it. So therefore, we're going to change this down here to 0.8. This still gives us a very transparent material, but now we start to see a little bit of reflection in the glass. Now when it comes to reflection, glass is actually a pretty interesting material, especially when you start lighting a building which has glass in it. If you have a lot of light on an outside of a building and not much light inside, or less light, like in a daytime, you would tend to get a lot of reflection in glass. And the opposite would be true if you were outside the building at night. Not a lot of light outside, but more light inside. There'll be a lot of transparency and not a lot of reflection. If you're inside the building, where there's not a lot of light outside, but a lot of light inside, again, you'll get reflection, not being able to see much outside. So one of the tools that I really like in the Arch and Design material is this tool here, BRDF. This stands for Bi-Directional Reflectivity Distribution Function. Essentially, it allows you to control the reflection based on the angle of incidence of the viewer's eye. 0 degrees reflection is looking directly at the surface, and 90-degree reflection is looking essentially parallel to the surface. If we wanted to look directly through the glass, we could set the 0 degree reflection to 0. So when we're looking directly at the glass, we will see through the glass. And when we look at a sharp angle and we want to get reflection, we can set this to 1. And we can play with these values. So once again, if we were a daytime scene, we might want to have that 0 degree reflection to be a higher value. If we're at a nighttime scene looking inwards, it might be that we don't have much reflection. And this value would be lower. Now you can see this last little parameter here controls actually the shape of this curve. And you can see that currently we're going to have very little reflection until we're hitting, it looks like about 60 degrees, and then it'll go up quite sharply. So let's smooth this out a little bit. Let's look at a curve shape of about 1. And we can change this, play around with it a little bit until we get something that looks linear. And let's see how that's going to affect what we've done so far. So we'll go ahead and re-render. So you can see here that we're getting a little bit more reflection than we did before, but we can still see through the glass, so it's not completely reflective. Let's go ahead and clone this view. And we'll dismiss our render dialog and a material editor. And what I'd like to do is actually move our camera so we get a very sharp angle on this glass. And you can see what our view will look like now. So let's go ahead and render that view and see what a difference it'll make. Let's render the entire view. So I think it's pretty easy to see what's happened here. This glass surface now, because of the angle of incidence of our camera, we've pretty well completely lost the ability to see through the glass that we had when the angle of incidence was closer to 0. So a very useful tool, something that can give you the ability to adjust the reflection of surfaces, not just because of the angle of incidence, but a little bit more dynamically than, say, entering just the reflection values